Yeah, we'll prove side angle side similarity theorem. Earlier we have discussed about basic proportionality theorem, converse of that one, vertically opposite angle theorem, and converse of that one. Now, as I said, out of those four, I am going to prove only one theorem, that is side angle side. What does it states? Side angle side. If the ratio of two sides, if the ratio of two sides, if the corresponding sides of two sides are respectively proportional, that means AB by DE is equal to AC by DF. Corresponding sides of two sides are respectively proportional. Proportional means they are having same length, or same, if you divide this, the ratio is same, and angle A is equal to angle D, then we can conclude that the two angles are similar. Are you getting my point? Once again I will say, what is in the exam, how they will ask is state and prove side angle side similarity theorem. So you need to write the statement. What is the statement? If the corresponding sides of triangles are proportional, corresponding sides of the triangle are proportional means sides corresponding, the side corresponding to this is this one, the side corresponding to this is this one, the sides corresponding to the sides of triangle are proportional and the included angle is equal, then the two triangles are similar. Once again, state and prove side angle side similarity. You have to write the statement. If the corresponding sides are proportional and included angle is equal, then the triangles are congruent. So how will you prove? It's very simple. Mark, now you can see that these two triangles are similar. Mark P and Q are 2 points on triangle DEF such that AB is equal to DP. As you can see the measurement, AC is equal to DQ. So this is small triangle and this is a big triangle. So you can always take that measurements. So here what I am going to prove, first thing is these two triangles are congruent. These two triangles are congruent. So can anyone tell why these two triangles are congruent? That is nothing but side angle side congruency property. What does it, what it says? If two sides and the included angle of one triangle are respectively equal to the two sides and the included of an triangle, then the two triangles are congruent. That means in triangle ABC, AB is equal to DP and DQ, AB is equal to DP and DQ is equal to AC. Also angle A is equal to angle D. This is by construction. This is by angle A is equal to angle D given. Therefore, are you getting my point? This, how we have to write is AB by AB is equal to DP is nothing but construction. DQ is nothing but AC by construction. These two by construction. Angle A is equal to angle D given. Therefore, triangle ABC is congruent to triangle DPQ. See, the letters should coincide. Angle A, angle D, both are there. BC, PQ, BC, PQ, and AC. AC is nothing but DQ. The letters should coincide when you write the congruency. Now, this is over. Therefore, now what you take this given condition. What is the given condition? Already given, no? What is the side? If the corresponding sides of if the corresponding sides are proportional, that means AB is equal to DE and AC is equal to DF. That is given. So write this here. AB by DE is equal to AC by DF. This is given. Take this given condition. Now, in place of AB, what you can write? In place of AB, because these two triangles are similar, you can write DP by DE. In place of AC, what you can write? AC, DQ. Since, why you have written like this? Since by construction or by side angle side congruency, by this triangle by triangle ABC is congruent to triangle DPQ. Now what you have to do is, look at this carefully. DP by DE, DP by DE is equal to DQ by DF. What is the converse of basic proportionality theorem? Converse. If a line divides the other two sides in the same ratio, then that line is parallel to the third side. Just now we have done now theorems based on that. If a line divide, this is the line, divide the other two sides in the same ratio, then that line is parallel to the third side. That means dP by PE is equal to dF by dQ, then PQ is parallel to EF. This is by basic proportionality theorem, converse of basic proportionality theorem. Converse of basic proportionality theorem. Now look at this here, come back here. This what you have written, if the ratio are same, we know that by converse that answer. Now see here, dP by dE, dP by dE. Observe this, d, what is that? dP by dQ. Here I have written now. dP by PE is equal to dQ by QE. dQ by QE. So what I am saying is, converse of basic proportional theorem is, if the line divides the other two sides in the same ratio, then that line is parallel to the third side. That means dP by PE is equal to dQ by QF. Then this line is parallel to this one. Or else we can say in another way also, this total length. Already we forget about this. Come back here. Now this whole thing I am erasing because it is confusing. Just see here, dP by dE, this length by this length is equal to dQ by dF. That means by converse of basic proportionality theorem. What is the converse of basic proportionality theorem? A line divides the other two sides in the same ratio, means this total length divided by this one or this length divided by this one, then that line is parallel to this one. PQ is parallel to EF. That means this line is parallel to this one. Now actually what we have to prove? We have to prove that, keep it in mind that we have to prove that this triangle is similar to this triangle. Already we have proved that this triangle is congruent to this one. Now, are you getting point? So far until here, whatever I have taught. Now consider triangle DPQ and triangle DEF. Now I want to prove that this triangle is congruent to this triangle. DPQ is congruent to DEF. Consider triangle DPQ and triangle DEF. Now this angle, since this is parallel to this, angle P is equal to angle E, also angle Q is equal to angle F. Why? Because that line is parallel to this. They are corresponding angles. It's clear? Now, what I said in the previous class, if in two triangles, if two angles are equal, then the triangles are similar. If two angles, if in two triangles, two angles are equal, then obviously third angle is equal. Therefore, the triangles are similar. That means here, this angle is equal to this angle is equal to this angle. Why? Because that line is parallel. Just now we have proved why this line is parallel and we have proved everything. So therefore, triangle DPQ is similar to triangle DEF. Why? Why? Because angle P is equal to angle Q, angle P is equal to angle E here, and angle Q is equal to angle F. So by angle or by angle property, by angle property, therefore triangle this triangle is similar to this. Just now I told no, two angles are equal, triangles are similar. So therefore triangle DPQ is similar to triangle DEF. Earlier what we have proved, just now what we have proved, triangle ABC is congruent to triangle DEF. Starting we have proved, no? By construction, mark a point PQ such that this triangle is equal to this triangle, therefore this side is this side. By SAS criteria, two triangle congruency property, this triangle is congruent to this triangle. Now what we have done, triangle B took this triangle and this triangle. Now we are saying that this triangle is congruent to this whole triangle, big triangle. This is triangle ABC is congruent to triangle, already proved. Now triangle DEF is similar to triangle DD. Triangle ABC is congruent to triangle DPQ. I have written the letters wrong. I'm sorry. Triangle ABC, triangle DPQ by SAS condition. SAS congruency. Now triangle DPQ is similar to triangle DEF, because just now we have proved this one. So therefore from 1 and 2 what you can say, ABC is congruent to DPQ. From 1 and 2 triangle ABC, this congruency means obviously it will be similar. Triangle ABC is similar to triangle DPQ. Also triangle DPQ, also triangle DPQ is congruent to, is similar to triangle DEF. Now combine these two. Therefore triangle ABC is similar to triangle DEF. That's it. It's very simple. Hence it is proved. So once again I just overall I will explain briefly. First, side angle side property. If in two triangles one pair of corresponding sides are proportional and they include one pair of corresponding sides, side already I explained corresponding means what? AB is the side corresponding to DE, AC is the side corresponding to DF. and the ratios are equal and one angle is equal, include angle is equal, then the sides are similar, then the triangles are similar. So construction, mark P and Q on triangle DEF such that this triangle is equal to this triangle is incongruent to this triangle. Just you prove it by side angle side. Now consider now and we have done some certain manipulations like converse of basic proportionality theorem in this. How we came to this, and therefore that line is obviously parallel to this one. Then these two triangles considered, PQ and DEF. Then this triangle is similar to this triangle. This triangle is congruent to this one. This is congruent to this triangle. Therefore, this triangle is similar to this one. That's it. Now, one more last theorem. After that, we can go for theoretical problems and numerical problems. Last theorem. Prove that the ratio of two similar triangles, prove that the areas of the ratio of two similar triangles is equal to the ratio of squares corresponding of the squares of any two corresponding sides of a triangle. I will explain clearly. I'm not writing this straight. Area of triangle ABC by area of triangle PQR is equal to BC square by QR square is equal to AB square by PQ square is equal to AC square by PR square. Now I am going to say once again, the ratio of areas of two similar triangles, already given two similar triangles. Two similar triangles means already given triangles are similar. Areas, ratio of their areas. Ratio, you know what is meant by that? Ratio of areas of two similar triangles. Ratio means this symbol I kept. Area of triangle means this triangle and this triangle I kept. Is equal to, what is saying is equal to ratio of the squares of any two corresponding sides. Is equal to ratio of squares of any two corresponding sides of a triangle. Corresponding sides, squares of any two corresponding sides of the triangle. Squares of any two corresponding sides of the triangle. What does it mean? Squares of any two sides of the triangle. Corresponding sides. Corresponding sides means already I have explained. What is the side corresponding to this? That is nothing but PQ. Side corresponding to this is PQ. What is the side corresponding to BC? BC, QR. What is the side corresponding to AC? Is nothing but PR. the areas of two similar triangles is equal to ratio of squares of any two corresponding sides. Any two corresponding sides means this side, any two BC by QR, any two corresponding sides of the triangle. Not only this side, you can say this side also, this side. Very important, and they may ask in exam, prove that the areas of ratio of two similar triangle is equal to ratio of the squares of the corresponding sides. Any two corresponding sides, in bracket parenthesis you can keep, or squares of any two corresponding sides. So it is very simple and easy, one of the easiest theorem. Now construction. Draw AD perpendicular to BC. Draw PS perpendicular to QR. You can do by construction. Next, just I am saying construction. Draw AD perpendicular to BC. Draw PS perpendicular to QR. Right. That means angle D and angle S. Here it is 90. Here also 90. Now already given triangle ABC is equal to similar to triangle PQR. Now let us prove it. Triangle ABC is similar to triangle PQR. Why? Already given. That means if two triangles are similar means what? What does it say? Two triangles are similar means corresponding sides are proportional. By SSS similarity, AB by PQ is equal to AS by PR is equal to AC by PR. Hold it. AB by PQ. AS. AS is not at all there. AC by PR is equal to BC by QR. Why? Because SSS axiom, SSS similarity. If two triangles are similar, then corresponding sides are proportional. Now, consider triangle ABD and triangle DQS. Triangle ABD and triangle, not DQS, it is PQS. Angle B is equal to angle Q. Why? Angle ADB is equal to angle PSQ. This by construction. Now I am asking why these angles are equal. Angle B is equal to angle Q. Can anyone say why this angle is equal to angle Q? Simple, because already they said that triangle ABC, triangle ABC and triangle PQR are similar triangles. Similar triangles means the angle should coincide, right? So angle B is equal to angle Q and angle ADB. Consider, now we are considering this triangle and this triangle. So what can you say from these two? Angle B is equal to angle B, angle B. Can anyone tell what is the conclusion of these two? Simple, that is both are congruent, both are similar. What I said, similar triangles. Similar triangles. If two angles are equal, it is clear, it is enough that the triangles are similar. Two angles are equal means the triangles are similar by angle extension theorem. Right? So now, therefore, triangle ABD is similar to triangle ABD is similar to triangle PQS because angle property. If two angles are equal, then the triangles are similar because obviously third angle is equal. Now, what you can write from this? AB by PQ is equal to AD by PS. AB by PQ is equal to AD by PS, or otherwise you can also write BD by QS because the triangles are similar, therefore corresponding sides are proportional. Now mark this as 1, mark this as 2. Now just I am erasing this all. What is triangle ABC? ABC area half into base into height. It is nothing but AD here. Next this one. Take this area of triangle ratio, area of PQR half into base PQR half into base is QR into height PS. Right. Now this and this can cancel. I want to erase this diagram. Now what you can say here, BC by QR into AD by PS. Now observe this carefully. AD by PS. AD by PS, what you can write? AD by PS. BC by QR into AD by PS. In place of AD by PS, I can write it as AB by PQ because from 2. AB by PQ from 2. BC by QR into AB by PQ. AB by PQ. What you can write here? In place of AB by PQ, you can write BC by QR from 1. Look at this. Look at here, children. Very carefully. I have written area of triangle ABC half into base into height, and I have cancelled something. BC will be AD by PS. But what is AD by PS? It is nothing but AB by PQ because the triangles are congruent. AB by PQ. Now, what is AB by PQ? This is nothing but BC by QR. Why? Because these triangles are similar. Therefore, BC square this by QR square. So that's it. So similarly, we can prove that the other side. Similarly, we can prove that other sides are proportional. So I hope you have understood clearly about similar triangles. It's a little bit difficult if you don't know the basics. But if you know the basics of earlier classes, then it is very simple. Once again children, let me explain all that what we have learned from part 1 to part 4. So first we did basic similar triangles, similarity and congruency. Similarity and congruency I have explained clearly. Congruency means one figure should coincide with other. Similarly means they should look same. And first thing is basic proportionality theorem, BPT. A line is drawn parallel to one side, then it will divide the other two sides in the same ratio. You take a paper and pencil and do experiments at home. You will find that ratio is same. Conversely, what is the converse theorem? If a line is parallel, if a line divides the other two sides. So here I am just going on explaining. I will give you the clear picture. If a line divides the other two sides in the same ratio, that means AP by PB is equal to AQ by AC, then this line is parallel to this one. That is the converse of basic proportionality theorem. If a line divides the other two sides in the same ratio, then that line is parallel to the third side. Next, vertically opposite angle theorem. What is vertically opposite theorem states? What is this? What does it state? Vertical opposite angle theorem. If just let me explain. The bisector of the vertical angle, the bisector of the vertical angle, this is the vertical angle. The bisector of the vertical angle divide the other two sides in the same ratio. That means if it is a bisector of the vertical angle, then this divide the other two sides in the same ratio. The other two sides means this one. So AB by AC is equal to BP by PC. And converse of this also we have learned. Next, SAS angle theorems. I have proved only one, the rest you need to do by yourself because it's not possible to do each and everything. Next, areas concept, last areas, A, B, C, P, Q, R. If the areas of two triangles are similar, then corresponding squares of the side are proportional. Yes, BC square by QR square. BC square by QR square, provided these areas are these two triangles are similar. Yes. Now in the next class we will be doing more about numerical and theoretical problems. Thank you very much. Have a nice day. Bye.